Alright, so welcome to your first video quiz. These PowerPoint slides will look a lot like what you've seen in class. It's just I'm going to embed questions within this PowerPoint for you to answer, and this is going to be part of your grade. So if you have any questions or if you need to stop the video at any time, you can stop. And I'll be pretty lenient. These really don't make a huge difference in your grade, but it's enough that I know that you're watching the videos and maybe taking some notes in class. And if you do those things, then your grade will definitely improve. So if you have any questions, make sure you let me know. Alright, so first we're going to start with place value. And so this is a whole number place value chart. And so the question here says, identify the place value for the given digits. Alright, so the first thing I want to do is I want to place these digits in this table. And so I always start at the end and I do them 3 at a time. So 6, 7, 8 goes right there. 0, 4, 5 right there. 1, 2, 3 goes there, and 9 goes there. And so if I want to identify the place of the, let's say the 5, it is in the, right here, it is in the thousands place. See, so using this chart right here, I can identify where every single number is located. 8 is located in the ones place, 7 in the tens, and of course I'm just reading straight up from the number. So at this point, because I placed it in this table, I can identify the location of every single one of these numbers. And remember, only one number per little box. So what if I said to identify the 3? You would tell me it's in the millions place. Alright, so it says here, name the following number. Now, that kind of sounds weird, but again, I'm going to start out doing the same thing. So I'm going to put these numbers in. Alright, so now we want to name it. So we want to put this into words. And you always name the first number, wherever it is located, you name it first. So we would say 7 million. Now we want to say 469, and you state the, basically you state every third position, but you never say the word ones ever. So we would say 469, 460, that's a 60, 69,000. And now we say 230. What I want you to notice here is notice where my commas are located where I named it. So my commas are where every one of the categories changes. So from thousands to millions. So notice there's a comma there after million. There's a comma there after the word thousand. And so you place a comma only in places where you're going to the next section. Okay, so you have a billion section, million section, thousand section, and a one section. But again, notice how I didn't put the word ones at the end. You don't ever name that one as ones. Alright, so in this problem, write the following as a whole number using digits. So I'm going to take these words and I'm going to put them in digits, in numbers. So 4 million, so I'm going to put 4 in the million section. Notice how there's a comma there. So now I'm going to go to the thousand section. 203,000. Notice how it's written 203, not 230. 230 is 230. 203 is 203. So make sure that you're pretty careful about that. 56. Now, I didn't say any hundreds there, so I'm going to put 56 right here, but you can't just have that hundred spot blank, so you have to put a 0 in there. So now we would write this out as 4, don't forget your comma, 203, comma, 056. Alright, so now if I want to round to the nearest 10 section, so let's see here. So this is asking me on 78, is it closer to 70 or is it closer to 80? And clearly 78 is closer to 80. Now here's the rule. You look at the 1 section. If the 1 section is 5 or greater, this number gets rounded up. If it's 4 or less, you just drop it, you put a 0 there, and you don't change the tens number at all. You don't round it up. So now this number right here, 6. What is 6 closer to? Is it closer to 0 or is it closer to 10? And it's actually closer to 10. Now look at 5,943. I'm going to look at the 1 section. It's a 3. So I don't do anything with the 4. I don't change this number at all. I make it 594, but I have to put a 0 on the end. Otherwise we've changed the value of the number altogether. So 5,940 is the closest tens, 10 and 80. Alright, so on this problem we are rounding to the nearest 100. So you want to look at the 10 spot. So you look at the tens. If it's 5 or greater, you round this number up. Notice how it is 5. So I want to round 9 up to 0, but look, I've got to carry another 1. So I would round this to 9,000. Now look at 98,364. Look at your 10 spot. Notice how it's 5 or greater. So I'm going to round the 3 up. So 98,400. And take a look at the 10 spot here. So because it's 4 or less, I just drop these, they go away, they become zeros, and I don't change that 4 at all. So this becomes 581,400. Alright, so whenever you add numbers together, you line up your ones, you line up your tens, you line up your hundreds, you line up your thousands, you line up your 10,000s. And I tend to put my bigger or my longer number on top. So 10,356, and below that I'm going to line up my thousands, 9, 8, 7, 5. And now we just add each column starting with the ones. 6 plus 5 is 11, you have to carry a 1. 1 plus 5 is 6. 6 plus 7 is 13. I've got to carry the 1. 1 plus 3 is 4. 4 plus 8 is 12. Carry the 1. 1 plus 0 plus 9 is 10. Carry the 1. So this becomes 20,231. Again, I usually put my longer number on top, 8034 plus 48, because you have to line them up with your ones and your tens. So 4 plus 8 is 12. I don't even know how to write. 4 plus 8 is 12. Carry the 1. 1 plus 3 plus 4 is 8. I don't carry anything, so 0 plus nothing is 0, and bring the 8 straight down. Alright, so we're going to translate this phrase into numbers, and we're going to solve it. The sum of 7 and 12. Sum means add. And what is 7 plus 12? It is 19. 59 increased by 32. That's another way to say addition. And then we're going to add. Alright, so now we're subtracting, and you're going to subtract almost in the same way. You still have to line up your ones, your tens, your hundreds. So I'm going to put 10,000 on top minus 235. But I can't take 5 away from 0, so I've got to go all the way over here, and I've got to borrow. I've got to borrow 10 basically, so this becomes 0. And now I have to borrow, so that becomes 9. This becomes 10, but now I've got to borrow, so that becomes 9. This becomes 10, but I've got to borrow, so that becomes 9. Now that's a 10. 10 minus 5 is 5. 9 minus 3 is 6. 9 minus 2 is 7. 9 minus nothing is 9. And that's it. I ran out of numbers. So this answer is 9,765. All right, so let's look at the next one. So I've got 9,734 minus 698. So I can't take 8 away from 4, so I have to borrow. It becomes a 2, so now I have 14. 14 minus 8 is 6. I can't take 9 away from 2, so I have to borrow again. 12 minus 9 is 3. 6 minus 6 is 0. And then bring my 9 straight down. So this answer is 9,036. All right, so we're going to translate these and then we're going to solve. But I want to warn you, whenever you see problems that are worded like this, sometimes with subtraction we have to be very careful with the order that we write these numbers. So whenever you see the word difference, just write the numbers exactly the way that you read them. So the difference of 72 and 25 means 72 minus 25. And so I'm going to borrow again. So I get 47. All right, now here's the thing though. Look at the second one. Subtract 8 from 17. That means you've got to reverse your order. So 17 minus 8, and I wind up getting 9 there. And this one is also a reverse the order. 10 less than 30. So 10 less than 30 means we're going to write it like this. Alright, so whenever you multiply numbers, multiplication can be written in a number of ways, and I've shown you 3 of them here on this page. So you don't necessarily have to line up your ones, your tens, your hundreds, and all that good stuff. But I do tend to put my my longer number on top. I just think it goes a little bit smoother. And so since these are both 2 digits, it doesn't really matter which one you put on top. And so to multiply this by hand, 4 times 4 is 16. 4 times 9 is 36 plus 1, 37. Now you do have to put a placeholder here. 1 times 4 is 4. 1 times 9 is 9. Now you add these babies. 6 plus 0 is 6. 7 plus 4 is 11. 9 plus 3 plus 1 is 13. So the answer here is 1,316. All right, so on the second one, I'm going to put my longer number on top, and I multiply. 4 times 0 is 0. 4 times 4 is 16. 4 times 8 is 32, plus 1 is 33. You have to put a placeholder, so 3 times 0 is 0. 3 times 4 is 12. Put the 1 up there again. 3 times 8 is 24, plus 1 is 25. And now we're going to add 0, 6, 5, 8, and 2 there. I'm going to put my comma there after the 8. So this answer is 28,560. Alright, so take a look at the last one. 26 times 0. Anything times 0 is just 0. So our answer here is 0. Alright, so now we're going to translate. The word product means the answer to a multiplication problem. So the product of 4 and 8, so we can write it like this. 4 times 8, and we get 32. Twice 11 means 2 times 11. 900 times 300 means 900 times 300. And here's always what I've done whenever I have all these zeros on here. I just put my placeholders there and I start at my 3. So now 3 times 0 is 0. 3 times 0 is 0. 3 times 9 is 27. There's my comma. So my answer here is 270,000. Alright, on this one, now we're dividing. So 90 divided by 10 is 9. 72 divided by 9 is 8. 12 divided by 3 is 4. And I just want you to see these 3 different ways to write division. So we can use the division symbol, We can use a fraction bar, or we can use a sideways fraction bar. Not my favorite way because sometimes that fraction bar looks like a 1. So just be careful with that bottom one. Make sure that you make that bar a little bit longer than the number so that it doesn't look like a 1. Alright, so now we're going to translate the following phrase into numbers and solve. The quotient is a fancy word for divide. So the quotient of 15 and 3. So we would write that like this or like this. Those are really the two ways I prefer. And to tell you the truth, this way is my favorite with the fraction bar. And now our answer to that is 5. Divide 36 by 12. You can write it like that. Answer is 3. 25 divided by 5 is 5. Alright, these are some symbols that you will see in this class quite often. So you've seen the equal sign before, but maybe you have not seen the not equal to. So this means A is not equal to B. Alright, you do need to understand your inequality symbols. Read them from left to right. Less than is this one. Greater than is the second one. Less than or equal to, notice the word or equal to. Can't be both. Can't be less than and equal to. And then our last one is greater than or equal to. Alright, so let's talk a little bit about expression versus equation. And this is something I do expect you to understand. If I talk about an expression, then I am talking about a group of numbers and or variables that are separated by pluses and minuses. There could also be some multiplication or division in there. And it will not have an equal sign. That means you cannot solve. Cannot solve. You can simplify though, okay? So expressions cannot be solved, but you can simplify them if possible. This can't be simplified because there's no like terms. I'm not really expecting you to understand that just yet. We are going to learn that in this class, but that's the difference between an expression and an equation. Expressions can only be simplified. Equations can be solved. So check out these. Equations have equal signs separating two expressions. So there can only be one equal sign in a problem, and so they will be separating expressions. Alright, so now we're going to translate this into words. So we read this from left to right. So this says 20 is less than or equal to 35. The next one, part B, says 11 is not equal to 15 minus 3. You could say the difference of 15 and 3 if you wanted to. I just usually write it exactly how I'm thinking it in my head. So in this case, in my head, I was thinking 15 minus 3. Okay, on part C, this says 9 is greater than 10 divided by 2. You could also say the quotient of 10 and 2 there. The last one says x plus 2 is less than 10. Alright, so let's take a look at this. We're going to compare some miles per gallons here for these various cars. And we're going to use the symbol either equal, less than, or greater than. Okay? So on part A, we're looking at the miles per gallon of a Prius. I'm just going to write the number just below it. 48. Miles per gallon of a Mini Cooper is 27. So the Prius is greater than the Mini Cooper on their miles per gallon. All right, part B, we're going to look at the Versa. The Versa is 26. The Fit is 27. So the Fit is greater than, but if you read it from left to right, we're saying that the Versa is less than the Fit. You have I used to learn this whenever I was a kid, that the mouth of the alligator eats the bigger portion. The Mini Cooper is 27. The Fit is also 27. My pen isn't wanting to write. And so those are equal to each other. The Corolla is 28. The Versa is 26. So 28 is greater than 26. The Corolla is 28. The Prius is 48. So the Corolla is less than the Prius. Alright, when we talk about exponents, we created exponents because it became a shorter way to write something over and over and over again. So if you have this expression right here, that is a bunch of 2's. But there's actually a shorter way to write it, and that's called using exponents. So the number that you're multiplying times itself is your base. So 2 would be my base. And how many times it's being multiplied is my exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put a little 9 up here. Make sure that your exponent is smaller than your number. We don't want it to say 29. 29 and 2 to the 9th are not the same numbers. 2 to the 9th is also not the same as 2 times 9. 2 to the 9th power is actually, let me make sure, it is 512. So 2 times 9 is 18. That's not the same. Okay? So make sure that you're very, very careful with that understanding. 2 to the 3rd does not mean 2 times 6 or 2 times 3. It does not mean 6. It means 2 times 2 times 2, which is actually 8. We do have special names for a couple of these, but anything beyond 3 we don't have a special name for. So if something is to the 2nd power, we call that squared. So a to the 2nd power is read as a squared. A to the 3rd power is called a cubed. It has a special name. A to the 4th power is just read as a to the 4th power. We don't have a special name for anything above 3. Alright, so let's write these in exponential form. Again, your base is the number that's being multiplied by itself. And then the exponent is the number of times it's being multiplied. 1, 2, 3, 4, 5, 6, 7. So I'm going to put a 7 up here. On the next part, 9 is my base. 1, 2, 3, 4, 5 is my exponent. X is my base. 4 is my exponent. And on the last one, a is my base. 1, 2, 3, 4, 5, 6, 7, 8. 8 is my exponent. Okay, order of operations is super important. So it's very important that we do order of operations the same way, because otherwise we won't match what we type into our calculators. What we do in the United States won't match the math that they do across the globe. So everybody universally follows the order of operations. And so that means if you're going to do math, you also have to follow the order of operations. Otherwise, things are going to be done out of order, and you won't get the same answer. So number 1, first thing you do is parentheses and other grouping symbols. Grouping symbols could be a fraction bar. That's a grouping symbol. That means you would do the stuff on top and then divide by the stuff on bottom. Absolute value bars are also considered a grouping symbol. Parentheses, brackets, these are all things that could be considered grouping symbols. Number 2, let's see here, says exponents. So after your grouping symbols, you do your exponents. Then you do multiplication and division in order from left to right. And I don't know how, but my last one got cut off. So number 4 is addition and subtraction in order from left to right. Okay, so that means that if you have subtraction to the left of addition, you will do subtraction first. So again, on number 3 though, part 3, if you have division on the left of multiplication, you would do division before multiplication. So that's what this means, in order from left to right. And they have equal priority. That's kind of important that you know. Addition and subtraction also has equal priority. Alright, so here's just a cute little picture, and this is how I was taught to remember the order of operations. Please excuse my dear Aunt Sally. The P stands for your parentheses, E stands for exponents, my dear MD stands for multiplication and or division, Aunt Sally, AS, stands for addition and subtraction. Alright, so on part A, we need to take a look at our order of operations. Step 1 says grouping symbols. We don't have any grouping symbols in this problem. Step 2 says exponents. We don't have any exponents. That's okay. We don't need to make any up. Step 3 says multiplication and division from left to right. So we do have multiplication, so that's the thing we're going to do first. So we would carry this 4 straight down. And now we need to multiply 3 times 7, which is 21. And now we're going to add 25 is our total here. Now check this out. If we had done or used grouping symbols, that means we got to do 4 plus 3 first. 4 plus 3 is 7. And then we're going to multiply that times 7, and you get 49. Big difference in those answers. Even though we use the same number and we use the same operation, notice how the grouping symbols changed our answer significantly. Alright, so first thing we would do in this problem is we need to do our grouping symbols first. So 5 minus 2. So everything else I'm just rewriting. Now remember, the parentheses next to a number, that means multiplication. And what we're going to do next is we're going to look at the operations that we have in this problem. We've got division, we've got addition, and we've got multiplication. So we need to do division and multiplication in order from left to right. And because those underlines don't overlap, we can actually do them both in the same step. If they overlapped, we could not do that. 18 divided by 6 is 3. Now I'm going to bring that plus sign down. 4 times 3 is 12. 3 plus 12 is 15. That's our answer here. Now the thing is, too, if you have a calculator, the TI-30X2S, then you could actually type in this problem exactly how you read it. Don't do it piece by piece. Just type in the whole thing, even the parentheses. The calculator does have that. And then you hit enter, and it should give you 15. And I do want you guys to practice with that. Alright, so that's it for the video quiz. And I hope that you learned some things and picked some stuff up. And if you have any questions, please let me know.